The video today is all about if-then statements. First of all, you need to know this vocab word, conditional. A conditional is a statement that can be written in if-then form. For example, we could write if P, then Q. In symbols, that would look like this, P arrow Q. That means if P, then Q. The hypothesis of the statement is the part that comes after if. So whatever statement P is the hypothesis, while Q represents the conclusion. Let's do an example together. This statement says, if you give a mouse a cookie, then he's going to ask for a glass of milk. So in order to identify the hypothesis and the conclusion, we need to check what is after if. So it says, if you give a mouse a cookie, so that means the hypothesis is you give a mouse a cookie. And it says, then he's going to ask for a glass of milk. So this represents the conclusion, Q. So you would just write that out on the line without the words if and then. These do not go with the hypothesis or the conclusion. Let's try another. This time it's not in if-then form. It says, when you give him the milk, he'll ask you for a straw. It may be helpful for you to write it in if-then form first, but let's see if we can identify the hypothesis and the conclusion here. So, you give him the milk, or when you give him the milk, then he'll ask for a glass of straw. He'll ask you for a straw. I don't know where that came from. So let's think about if this would make sense in an if-then form. If we included the word when, it would say, when you give him the glass of milk, then he'll ask you for a straw. That wouldn't make sense. So we're not going to include when in the hypothesis. We'll just write that the hypothesis is you give him the milk. The conclusion, he'll ask you for a straw. So let's make sure it makes sense in if-then form. If you give him the milk, this comes directly from the hypothesis, then he'll ask you for a straw. That's directly copied from the conclusion. It makes sense in if-then form, so this hypothesis and conclusion must be correct. Let's talk about the truth values for an if-then statement. For an if-then statement to be true, both the hypothesis and the conclusion must be true. So P and Q must both be true in order for P implies Q to be true. If the hypothesis P is false, the whole statement P implies Q, that's the whole statement, is considered true by default. The reason for this is if P is false, that means you're not really testing out what would happen if the hypothesis was true. And if you're not testing it out, then you just have to assume that it's true by default. Let's practice determining the truth values. So it says, if it's true, explain. If it's false, give a counterexample. So here's the statement. If you divide an integer by another integer, the result is also an integer. So an integer means any number such as -5, -3, 0, 1, 10, etc. It doesn't have a decimal part to it. So if you divide an integer by another integer, is the result always another integer? This truth value would be false because I can come up with a counterexample. So as a counterexample, I could say, take the integers 5 and 2. 5 divided by 2 is not equal to an integer. So that proves that this statement is false. Okay, this one says, if next month is August, then this month is July. So the hypothesis of this statement is next month is August. The conclusion is this month is July. Does this conclusion follow directly from this hypothesis? Is this always true? Yes. So the truth value is true. In our explanation, we can say, since P is true implies Q is true, the whole statement P implies Q must be true. Alright, let's try another. If a triangle has 4 sides, then it is concave. So this hypothesis says a triangle has 4 sides. The conclusion says it is concave. So this hypothesis, a triangle has 4 sides, there's no way that this can be true. So this hypothesis is always going to be false. A triangle has 4 sides, there's no way that could ever be true. Remember we said if the hypothesis is true, the overall statement is if the hypothesis is false, the overall statement is considered true by default. So as our explanation, we'd say the hypothesis is false, so the overall statement must be true. By default. Because who knows, maybe someday we'll discover a triangle with 4 sides. Who knows? We can't test out if this conclusion is true or false, so we just for now are going to assume the best and we'll assume it's true. Okay, also I just want to make a quick note. The word concave, this means that it's a shape where one of the angles goes in. So for example, this shape. Most of the shapes we are dealing with are called convex shapes, and they would look something like a regular shape that you're used to. All the angles are less than 180 degrees. Okay, next we're going to talk about converses, inverses, and contrapositives. I'll tell you the definitions of each of these. So a conditional statement, we already know that's P implies Q. A converse statement is where you switch the hypothesis and the conclusion. So if we have P implies Q, we're going to switch those around. So the converse is Q implies P. We've already done this. We said the hypothesis is you give a mouse a cookie. The conclusion is he will ask for milk. So for a converse of this statement, we'll just switch it around. So we'll switch the hypothesis with the conclusion. Next, the inverse. You negate the hypothesis and the conclusion. So you would do not P implies not Q. See if you can write that one out on your own. And finally, the contrapositive, you have to switch them and negate them. So it would look like not Q implies not P. So for example, if he does not ask for milk, then you will not give a mouse a cookie. So notice we switched the hypothesis and conclusion, and we also added in the word not to both parts. The reason I highlighted conditional and contrapositive in the same color and converse and inverse in the same color is because they will always have the same truth values. So if a conditional statement is true, the contrapositive is also going to have to be true. Similarly, if one is false, the other must be false. And it works the same for converse and inverse. If one is true, you know the other is automatically going to be true as well. They always have the same truth value. I'd like you to reflect on this question tonight. Write your own example of a conditional statement, an if-then statement, and then write the converse of that statement. Thank you.